more than just okay.
All right, good morning and welcome back. Pre-Calc section 9.2 today, coordinates and complex numbers. Hope you're doing more than just okay. So we're going to start in on the next section here. We left off on 9.1, which was coordinate pairs and graphing. So now we're going to take that to actually graphing polar graphs. So away we go. Okay, very simple objective today. We're just going to graph polar equations. So that is the plan. I'm going to show you how to do that, how to use your calculator, how to set that up. From a quiz standpoint, when we get to that point, you're just going to have to do a chart and list your coordinates and then draw the picture. So that may not make sense right now, but once we see a couple, that should help. Okay, polar graphs. We're used to parent graphs. We've seen this in the past where we've dealt with quadratic functions, absolute value, cubic functions. You've seen all of those. For polar graphs, our base unit is going to be r equal to sine theta and r equal to cosine theta. You see that right here. Polar graphs are functions. However, we cannot apply the vertical line test. That's valid in a Cartesian coordinate plane when we just have x and y axis. When we have a polar coordinate plane, that vertical line test is no longer valid. So when you look at r sine theta or r cosine theta, those are actually circles on a polar coordinate system, which clearly would not be functions on a normal graph, but in this case, they are. All right, to graph these, we're going to use our calculator. You'll see this on the next slide. I'll show you a screenshot of your calculator, but you turn your calculator on. You're going to hit the mode button, and you want to change, in the mode button, you want to change that to polar. I probably should have started this off at the start of the video and said this, but anytime you need to, you can pause or go back, obviously. But we would change our mode to polar, and then you can set your scale. In this case, instead of x min and x max, y min, y max, what we're going to have is our theta values, and you're going to set those to 0 to 360 or 0 to 2 pi if you're in radians. So again, if we're in degree mode, we'll use degrees. Obviously, in radians, we'll go there. As far as our step setup, typically we'll use 10 or 15 degrees. I usually like using 10, but you could use either one. In radian mode, pi over 12. Pi over 12 is 15 degrees. And then here's our x and y range. You can see that -5 to 5. And again, that may change depending on our graphs. So we will only graph these functions with our calculator. And if we have to do them by hand, we just take our values from the table. So again, all the calculating will be done for us on our graphing calculator. So again, if you turn your calculator on, and again, hit pause anytime we need to. Turn your calculator on, hit the mode menu. This is what I'm talking about right here. We need to switch this to either degree or radian. I just left it in degree for right now, but you want to go to polar. So we want to be in polar mode instead of function or parametric. Depending on the question, you can be in radian or degree. I just left it in degree for right now. Okay, your window settings. If you're in degrees, we would do this. What we're talking about here, 0 to 360. You can go by 15s or by 10s. And again, I went -5 to 5 on the x and y. If you go in radians, we'll go 0 to 2 pi. As soon as you type in 2 pi right here and hit enter, it's going to change that to a decimal. Same thing here for your step, pi over 12. That's the same as 15 degrees. As soon as you hit enter, it's going to change it to this 0.2617 decimal. X and Y scales are the same. So again, that's the setup from the graph. So now going back to these parent functions, what are we dealing with? I just started here with cosine theta. So if you hit y equals on your calculator, it's going to give you R1, R2, R3 in polar mode instead of Y1, Y2. And we can see this right here. I just typed in cosine of theta. How do we get theta? That's the variable key. So when you're in function mode and you hit the X button to type in an equation, or if you're in parametric, you hit the variable, but the X button, you get T. In polar mode, we get theta. So we have cosine of theta. We're going to start here. You can see I just went here by theta, that's fine. Our table setup went 0, pi over 12. Again, if you did in degrees, that's cool too. You just do 0 and 15, and this would go 0 to 360 by 15s here. And I put this on auto, so it automatically calculates. What you see is we get a circle, and that's basically what I want you to see from this, is that we get a circle here when we do cosine of theta. If we were to do sine of theta, we'd also get a circle. We'll show the side by side in a minute. If you do -5 to 5 on your window here, you're going to get a distorted picture. It's going to look more like an oval than a circle. The way you solve that, you hit zoom and hit 5. So that'll square up your viewing window, much like your TV screen. Your TV is wider than it is tall. So is the viewing window on your calculator. This viewing window is wider than it is tall. So zoom squares us up corner to corner, left to right, and it actually looks like a circle. You know this about cosine. Cosine of 0 is 1. As we start going around our values, we get back to 0, then we get down to -1 and back to 1. So that's what's happening here with our values. So that's why it starts here at 1 and goes around. Let me go to the next page here so you can see this. So again, this is on a polar grid now to scale. So I let each one of these be a quarter. So you can see the fourth ring out, I made 1. So this is the same graph you saw on this slide. Only now here you got, again, cosine of 0 is 1. If we go to 45 degrees, cosine is square root of 2 over 2, which is 0.717. We get to pi over 2, or 90 degrees, cosine is 0. And then we keep going. When we get, as we go around these values here, you'll get negative. So like when you're here, you get negative, reflects it back. So, or excuse me, in quadrant 3, rather, you get negatives. So when you're over here, you get -1, kicks it back here. When we get into quadrant 4, we get the positive values for cosine. Gives us our circle. Sine is very similar, only now we start at 0. And then as we get to pi over 2, we get to 1, back down to 0. When you get down here, quadrant 3 and 4, that's when we start getting into negatives. So when we get right here, that's a negative value, and here, negative, and so it keeps kicking them back around to make this circle. So that's really the difference between the two. You see cosine here looks like it kind of goes to the right to 1 and around, and sine starts at 0 and goes up and back down. If you change the radius, if you change the value in front of sine or cosine, like these graphs here, all that is going to do is change your radius. So instead of having a circle of radius 1, this would be a circle of radius 2. This one here would be a circle of radius 3. So for example here, let me take this sine function, 3 sine theta. So sine theta went to 1. If we did 3, it would go all the way up here to 3 and then back down to 0. So that's the difference there between 3 sine theta, sine theta. So that's a very basic integration, very basic intro to graphing polars. It's basically the first half of our notes, so we're going to stop there for today. We will start here when we get into other pictures, roses, cardioids, so forth. You can see that if you look ahead in the notes. But this is where we're going to start for day 2 of the notes. So we'll stop right here. Again, we'll make a table as we go. I'll show you how to do that. I'll be talking to you soon if you have questions on the review worksheet and anything from section 1. Again, hope all is well. Be safe, and good to have you back.